Thank you for the introduction and also for the invitation to share some of the work we've been conducting in Zimbabwe here. So I work on a neglected tropical disease called Schistosomiasis. It is caused by a helminth parasite. And today I'm going to describe some of the work we've been doing, particularly focused in Zimbabwe. The parasite is represented here, adults, males and females. The disease is called schistosomiasis, or commonly known as bilharzia or snail fever. It is caused by freshwater borne parasites, and this is particularly important because with the problems in provision of safe water and sanitation, you'll find out why this is very difficult to control. But this is the infective stage, and it is released from the intermediate host snail, and then people come into contact with it with their day-to-day chores. It's a very old infection. We have records of it in the Bible and in the Dead Sea Scrolls. Schistosoma haematobium, which I focus on, is the most prevalent human schistosome species in Africa, with about 200 million people infected. Now, some of you will probably know of these two cases, Prince William with his famous infection in 2003, Chris Froome, who attributes his success at the Tour de France last year to the treatment of bilharzia. I'm not going to focus on those today. I think they've had enough media coverage. I am going to focus on a different group of people, and it's these people, people in rural Africa, where there's no safe provision of water and there is no sanitation. And I'm going to describe some of the work we've been doing with them. So if we have a look at the disease, it's recently been renamed by the WHO urogenital schistosomiasis as opposed to just urinary schistosomiasis, and I hope to show you why. The disease has many clinical presentations, but the most famous and most well-known is hematuria, which is blood in urine, represented here by some of our samples from Zimbabwe. Also, bladder cancer. So this is particularly important at this forum like today, where we're looking at communicable and non-communicable disease. I hope to illustrate that the line between the two is very gray. Bladder cancer is the fourth most prevalent cancer. In a lot of the males, it is largely due to schistosomiasis. Last year, and in fact this year, the World Health Organization reclassified schistosomiasis as a group 2 carcinogen, so very, very important. Also, something that's becoming very prominent, schistosomiasis is very important in reproductive health, both males and females. So we have female genital schistosomiasis and male genital schistosomiasis. Another one which seems vague but very important, a lot of studies showing improved memory and cognition in children when you have treated schistosomiasis, so affects childhood development. The egg-induced pathology, which is a lot of what most of us are familiar with, leads to the damage we see here and here in the liver and the spleen. So this poor child is only 8 years of age, and he's got an enlarged spleen and liver as a result of schistosome infection. If he'd been treated earlier, this wouldn't have happened, and we'll come to look at that in detail later. Pathology is progressive starting in young children, so this is very, very important because it begins to show you where you must target your control strategies. So how do we control schistosomiasis? The whole ethos of schistosome control is to control morbidity. Failing that, we control infection. It is done using this drug, Praziquantel, which was developed by Bayer. It's now lost its patent, which is good news. It's taken as a single dose. It is safe and highly efficacious. Thanks to global efforts, it is now provided very cheaply at 50 US cents per dose. It works synergistically with the immune system, kills adult worms, and reverses those early pathological processes, and it reduces reinfection rate. If we look at the global mandate for the control of schistosomiasis, it's done through mass drug administration or preventative chemotherapy. Preventative chemotherapy because you are treating infected children to stop them developing pathology or morbidity. So this has been guided by two sort of world drives. The first one was the Millennium Development Goals, MDG 6, which aims to combat infectious diseases, and schistosomiasis falls under other. In 2001, the World Health Assembly set up Resolution 54.19. The mandate of this is to treat at least 75% of all school-age children at risk of schistosome infection morbidity by 2010. Now, I highlight school-age children there because that is very important. So as we all know, it is always good to look at how your efforts have gone and what the effect has been. We look at what happened in relation to the MDG6. 236 children were targeted for treatment against schistosomiasis. The World Health Report in 2011 showed that by 2010, we'd only managed to reach about 13% of those. And this is appalling. And in fact, it's the least coverage that was achieved of all the helminth infections that were targeted by the MDG6. So what are the reasons for this? There are two main reasons. The first one is that preschool children, so children typically aged between 1 and 5, are excluded from mass drug administration programs. The second one has been coverage in countries where there's no mass drug administration program. So very few countries have set up national control programs. So my research group and I, and our collaborators in Zimbabwe, decided to tackle these two issues and have a look to see if we can do anything to improve the uptake of Praziquantel. The first one we addressed was the health inequity with preschool children. So we wanted to know why children were excluded from treatment. Clearly, we thought they were infected. We've seen them exposed with their mothers. So why were they not being treated? Well, we were given a list of some very interesting reasons why children are excluded. The first one was that, well, we're not sure that the children are exposed. 1-year-olds are too young to go to water. The second one was, well, even if they get infected, their infection levels are so low that we don't think this has any clinical consequences. So the role of low infections in morbidity was questionable. The third one was I explained that Praziquantel requires synergism with the immune system in order to kill the parasites. While these children were considered to have to be too young and therefore be immune incompetent, so they couldn't work with the drug. Finally, when Bayer did their clinical tests for licensing of Praziquantel originally, they included children aged 6 years and above. And because we didn't have evidence on efficacy or safety of Praziquantel in preschool children, it was taken that lack of evidence is evidence of lack of efficacy and safety. So we decided that we would challenge these myths. We would create an evidence base on which we could then make an informed decision. So the next few slides will explain how my research group went about this. The first one was to look at exposure, infection, and morbidity. Clearly showing pictures of little children enjoying a swim is not enough to show evidence. So the first thing we had to do was to demonstrate that this water was infected and also that these children went to the water often enough to pick up infection. Okay, so we've got exposure. How about infection? We conducted a study in children from 1 to 5 years all the way up to adults in 40 years, and we quantified infection. What this shows is that these 1 to 5-year-olds do carry considerable infection levels. And actually, these infection levels are comparable, if not greater than in their caregivers, who are not only eligible, but also targeted for Praziquantel treatment. So this really was a big health inequity. But again, we've satisfied the people who are suspicious about exposure and infection. We need to show that actually those infections translate to morbidity. So we've done that, and actually this is a recent study in my group, but we've done several of these. And here what we have 1 to 5-year-olds in red, and the target group for current MDA, 6 to 10-year-olds in black. And if we use a series of morbidity markers starting from hematuria all the way to clinical examination for schistosome-related morbidity, what we're actually seeing is that these 1 to 5-year-olds are carrying significant levels of morbidity, and that actually we shouldn't ignore that. So this is work we published in our process to build up the evidence. And what we conclude is that preschool children are infected and they do exhibit significant morbidity. Then we went on to challenge the immune system theory. We were interested in providing immune response data on children aged between 1 to 5. And we did this by looking at both antibody responses and cellular responses. So the first thing we were able to show was that children, so this is a study based in children from 1 to 5 years of age, children were able to mount antibody responses directed against all the parasite stages, so the infective stage, the egg stage, and the adult stage, so they could mount antibody responses against that. But more importantly, we were actually able to show which of those parasite proteins these antibody responses were directed against. We then went on to look at the cellular responses, because obviously you need the cellular responses in order to have an effective immune system. So through a series of really sophisticated, just basic scientific research studies in our lab, which focused on cytokine responses and flow cytometry and memory responses, we were able to analyze immune responses in children aged 1 to 5. We put all that together, and basically we conclude that preschool children do mount schistosome-specific responses. And in fact, these responses do synergize with the worms in order to kill them after praziquantel has been administered. The next one was to look for evidence of praziquantel safety and efficacy. So this was a study which was funded by the World Health Organization. So in 2008, the World Health Organization funded 3 groups to work in Africa and look at or evaluate safety and efficacy in the preschool children. My research group was one of those groups, and our mandate was to look at Schistosoma haematobium. So our approach was to look at the target age group, which is the primary school children aged 6 to 10. We looked at the side effects they get after praziquantel, and you don't have to go through all those. All I can tell you is that the most frequent side effect reported is stomach discomfort, and it is reported in about 34% of the children that take the drug. We compared that to what we see in preschool children, and actually we only had 4 cases out of 105. So this is significantly lower than what we actually see in the children who are targeted. So we're happy with the safety issue. Let's have a look at the efficacy issue. So we're looking at infection intensity measured as egg count. So in children aged 1 to 5, we were able to significantly reduce infection through a single administration of praziquantel within 6 weeks. And in fact, when we look at the cure rates and the egg reduction rates for this group of children, they were above 95%, which is really very good compared to the 90% you get in this age group. So we were able to conclude that actually praziquantel treatment is safe and is efficacious in preschool children. So we were quite happy with that, and ourselves and the 2 other groups were convened by the World Health Organization to put our findings in a report and then also to make recommendations. So this is the report which was published by WHO in 2011, which we helped to prepare. And 3 important things in that report. The first one is that children do need praziquantel treatment. The second one is that praziquantel is efficacious and safe in preschool children, and that preschool children should be included in MDA. So we were very pleased about this, because that means 40 million children who are schistosome infected in Africa are now eligible for antihelminthic treatment. And this has now been the WHO sort of song since the publication of the report. And I couldn't put it any better than one of my colleagues did last year in his shouting publication in Trends in Parasitology. So wherever we go now, we say, let these children be treated. There is no reason why they shouldn't be included in mass drug administration. So we've achieved our first goal. Let's have a look at how we increase coverage by instigating a mass drug administration program. So we decided to do this in Zimbabwe, so we wanted to get our research into policy and practice. So there is Zimbabwe. You've seen the map of Africa. We needed to know current levels of infection, so needed to convince the Ministry of Health. We needed to formulate a control policy and a plan of action, as well as to evaluate the safety and the success of any intervention. So in 2010, we conducted a national survey. This is a map of Zimbabwe where we've put in infection levels. So the size of the dot is commensurate with the prevalence of schistosomiasis. What we have is national prevalence of 35%, ranging from 0 to 80% in some regions, but very important. And a lot of the 8 to 11-year-olds we surveyed, 100% of them were infected. So how did we go about this? We need to make an operational case. So we did, again, a lot of laboratory studies as well as field studies to convince Zimbabwe it's still safe, also that it can fit in with ongoing integrated health activities, and also that we do not exacerbate malaria incidence or morbidity, because these areas occur where there's endemic schistosomiasis and malaria. Then we had an MDA pre-run. So in one school, we conducted our MDA. This is one of my colleagues checking that the young girl here has swallowed her tablets, because we want to be able to tell the difference between drug failure and not drug taking. So we were able to tell the government of Zimbabwe that school-based mass drug administration is safe, efficient, and cost-effective. With that information, the government of Zimbabwe set up a 5-year national control program. It was launched in 2012 with all the fanfare and excitement that happens with these kinds of activities. The Minister of Health was the first one to take the drug, which then made everybody very happy to follow suit. But we were particularly pleased because 1.2 million preschool children who would have otherwise been ineligible for treatment were included. And these children are now in their second round of treatment. So we were quite pleased. We've now got our 2 aims achieved, and we thought this was the end of it. It wasn't. So where do we go now? When I explained what we had done to Alan Fenwick, who was the head of Schistosome Control Initiative, he said, oh, good, you should be the independent monitors and evaluators of Zimbabwe's National Control Program. So we now are. And what we're doing is, in 20 sentinel schools throughout Zimbabwe, we're following the long-term and short-term effects of schistosome infection. So looking at efficacy at reducing infection and morbidity, adverse events, also looking at general health of the host, so hygiene hypothesis issues are tackled here. And we're also looking at longer-term effects on population structure of the parasites, so development of drug resistance. On the global scale, we've been inspired by the latest resolution from the World Health Assembly, which is urging us to eliminate schistosomiasis. So this is not going to happen easily because we need improved coverage, sustained control, which my research group is working on a lot, and as well as additional tools such as BioVax here for vaccination and snail control. My immediate challenge is that at the time we set up the policy for Zimbabwe, I suggested that we have an MDA register which records every child that is treated. It turns out there are 3 million children. And 4,000 schools each keep one of these registers every year for the next 5 years. These are now sitting on my desk for the first 2 years. I am not happy about this, but I'm sure there's some statisticians in the audience who will have a field day with that. The second one is on the global scale. This is a big challenge, and I was very interested to note that Africa is the only one where you've got your infectious diseases still rising. One of the reasons for that is if we look at MDG 7, which looks at water and sanitation, Africa has the least provision of water and sanitation in the world. And these actually pink regions are where you have those facilities least. The pink here is actually from a report from the WHO progress for MDG 6, which shows that those are the countries where they are not on target for meeting this resolution of increasing access to safe water and sanitation. For this, we really need a concerted interdisciplinary approach and dialogue between different ministries, different stakeholders, and different scientific disciplines. And I'm hoping that this meeting today will begin to give us ideas of how we go on from there. Quick thank you to all our colleagues who have been involved in this work, particularly the children who have taken part in the study, holding their consent forms, to, not only to take part, but to have their photographs shown, and also all our funders and yourselves for your attention. Thank you.